Hey, Bowen, good morning.
Hey, Eddie, how are you?
Doing good, doing good. Thank you.
Yeah, thanks for joining. Uh, okay, I think we're live on YouTube, so let's get started. Um, yeah, thanks everyone for joining this call. I think maybe some more validators going to join. But yeah, so the purpose of this call, as I mentioned in the description of the event, is to discuss and hopefully finalize our decision on adding the SEC validator keys. So I'll first give some background on this whole story, and then I'll also talk about what we have discussed so far, and what we have agreed on, and what we have disagreed on, and then we can discuss those disagreements, and I think also let people ask questions if they have any, especially for validators who may not be fully familiar with the inner works of the protocol. Okay, so let's start. Let's get started. Maybe let me share my screen. Okay. Hope everyone can see my screen. Yeah. So I've written this post on gov.near.org on adding SAC validator key to enable pessimistic bridge. So basically, the reason why we want to add this SAC key is that currently the bridge on the near to east direction, we rely on optimistic, or that part is optimistic, and we rely on challenges to ensure the security of that part. And this suffers from the same problems as other optimistic approaches. The challenge periods, there's really no rocket science as to how long it should be, and usually if you want to make it very secure, you have to make the challenge period quite long, and this hinders usability quite significantly. And all the and then the reason behind that is really that on the Ethereum side, there's no precompile to verify ED2519 signatures. However, there are precompiles to verify SEC 256K1 signatures. And because of that, Alex came up with this idea that we can just add a SEC validator key addition to the ED25119 key, and it will sign this message, which we can discuss later. It basically, the idea is it will sign some message, and on the bridge side, we can verify the SEC signatures for that message, and the message would allow us to ensure that the transfer on the near to east side also works. And I think we did some calculation here regarding gas. I'm not super familiar with this stuff, so I think I would just say that it is feasible to have to verify all the SEC signatures in one Ethereum block, and therefore it will make, assuming we use this scheme, which we can discuss later whether we want to use this exact scheme, but assuming we do that, the transfer from near to Ethereum will be almost instantaneous. Basically, it will be done once our light client block is verified on Ethereum side. And it will reduce the transfer time from near to Ethereum side from 4 hours currently to I think within 1 minute, which is a huge deal for the usability of the bridge.
So Bowen, yeah, a small addition here. So at the moment, since the bridge is optimistic, the end users that are doing their transfers over the bridge, they need to wait 2 distinct period of times. First period is to wait until some block of the near is relayed to Ethereum. And this can be, and since we are relaying only one block per epoch because of the high fees in Ethereum, this period can be anywhere up to 12 hours. Well, actually 13 hours at the current chain state. And then it is followed up by a perpetual 4 hours challenge period. And we cannot remove this 4 hours. While this 13 hours if we are going to relay, for example, more frequently blocks every 10 minutes, then we can reduce this to 10 minutes. But obviously, we are going to pay much more for the relaying, but it doesn't matter. With this approach, we can remove these 4 hours completely. And in case we are relaying frequently our blocks, users are going to do the withdrawals from near as fast as possible. And the thing that is more important, even more important, that if there is a user that really would likes to withdraw immediately all of his funds or like some of his funds from near to Ethereum, he is able to do this by self-relaying the block with his withdrawal transaction. So he sends the relaying transaction to near to Ethereum. So he like supports the bridge infrastructure with this transaction, and then he doesn't need to wait for additional 4 hours to finalize the withdrawal. So that is the major difference in between the pessimistic bridge design and the current optimistic design that is in place.
Yep. Yeah, thanks,
and
Alex,
one short note about the gas calculations. So currently, one relayed block of Rainbow Bridge, it takes more than 6 million Ethereum gas. While in this calculation, we see that it is going to be somewhere around, I don't know, 200,000. So it is like 30 times less than what we are paying right now. And obviously, if we are going to spend the same amount of money for relaying of the blocks, then we can relay things like 12 hours divided by 30, and you will get like every 20 minutes or something like that. And so without raising the cost, with this approach, instead of up to 17 hours of withdrawal, we will be having 20 minutes withdrawal for users from near to Ethereum.
Okay. Yeah.
Actually,
yes.
I have one note. So from what Alex just said, it seems that this pessimistic design is inherently cheaper in terms of gas. It's not true, actually. The problem is that current optimistic bridge is not really efficient at all. And in fact, optimistic bridge can be made use less gas than pessimistic bridge because in fact it doesn't need to verify anything unless there is a challenge, and we assume that there would be no challenges because the relayers don't want to lose their money on being challenged. So actually this pessimistic bridge would be a bit more expensive in terms of gas compared to an efficient optimistic bridge. But the problem is that there is a challenge period, it's 4 hours, and in fact, with optimistic bridge, you cannot relay blocks faster than challenge period. So once you relay a block, you must wait those 4 hours until you can relay the next block. So the actual waiting time even if the blocks are relayed at maximum speed for an optimistic bridge would be between 4 and 8 hours, depending on how recently the last block was relayed. And this time can only be reduced by reducing the challenge period, which can reduce security because the watchdog may have not enough time to challenge an invalid block if it happens to be submitted. And with optimistic bridge, blocks can be relayed about as quickly as Ethereum blocks, but of course, because of the gas cost, they probably won't be actually relayed that rapidly. But still, I think one block every hour, maybe every half an hour is quite feasible with pessimistic bridge.
Okay, yeah, thanks, Alex and Evgeny for explaining the more details on the bridge side. Yeah, it's I don't have a very good knowledge there. Okay, so that's pretty much all the background information for I guess the motivation for this change. So does anyone have any question regarding this part on why we want to do this change? Okay, looks like no. I assume everyone's is on board with the motivation of this change.
Yeah,
okay,
one
now,
short comment here. Here.
Mhm.
Alex Gidanov was mentioning that potentially in the future this upgrade like is a prerequisite for allowing a permissionless bridge to the Bitcoin, because Bitcoin
Yes.
uses the same cryptography, and there is a scheme how you can organize also fully permissionless bridge to Bitcoin.
Mhm. Yeah, good point.
It's just like some additional thing that is like in a distant future.
Right. Yeah, absolutely. Okay, so now that we're clear on why we want to do this change, let's actually see how we are going to do this change. So basically, there are several changes on the protocol level that we need to make. So one obviously is that we actually need to add the signature somewhere. So the plan is to add this signature to blocks of course first to approvals, and then we add those signatures in the block body instead of block headers we have for the current ED2519 signatures, because we don't need to verify them in the headers. And then the obvious, that's the, I guess, easier part. The bigger problem is that we need to introduce a new validator key, which is this SAC 256 K1 public this key pair, and that makes things more difficult because this requires us to modify how staking works. So there are different proposals as to how to do this. So the current staking, well, for people who are not familiar with this, the current stake action, it basically takes the balance, which is the amount of stake you want, and your public key. Basically, this is the public key of your validator key pair, which is ED25519 key pair. And then basically the idea is that we extend it to include this SEC key as well. Now, there are multiple problems with this. Well, first of all, this is a protocol change, and it also changed the transaction structure. So this means that we need to change everything on our tooling side to support this. But that's not even the biggest problem. The biggest problem is that currently we have all the staking pool deployed with this staking pool contract that is written by the NEAR team and is deployed through the staking pool factory, which is deployed. Because of how this is set up, the staking pool is permissionless, and it cannot really modify itself. The problem that comes with that is that what happens when the delegation to the staking pool happens is that the staking pool will send a receipt with stake action, and that part is within the contract. It's done within the contract. And we don't have a way to easily modify that. And to solve that problem, there are multiple different proposals. The first one is basically here what is proposed by, well, okay, maybe let's go through the first one is, well, literally we say that, okay, we abandon the staking pools. We write a new staking pool and we deploy a new one, and then we ask people to migrate to the new pool. The problem with that is that it's a huge pain for the validators, because validators, most of the validators today don't know their delegators. It's a kind of permissionless setup, and they pretty much need to tell to broadcast that hey everyone, we migrate to a new pool, please withdraw your delegation and then redelegate to us. I mean, that is just a huge pain, and I don't think validators would be happy with that. So to solve that problem, there is a new proposal. So this is proposed by Alex Gidanov. The idea is that we add a new action, which is called set validator extra key. That includes your sec key, and this would be signed by your current ED2519 validator key to add this to basically bind this sec key to the staking pool, which is the validator account ID. This kind of works. However, the problem is that this is ad hoc, and when we introduce a new action, essentially we have to maintain forever, because archival nodes needs to be able to apply the entire history, and which cannot. Yeah, and this will not only incur additional changes to all the toolings, but also the additional protocol changes need to be done in order to account for this new action, which is also quite suboptimal. I mean, on the validator side, yes, their life is a bit easier, but from the changes on the protocol side, it is quite annoying. And because of that, basically we concluded that neither of these options is really optimal, or and we want to have a better way of doing this. So what Ilya proposed later is that we can essentially do the following. We can say that because everyone is just using the same staking pool contract today, which is deployed by Near Foundation, they're all the same contract, and we can simply say we have a new contract written. Let's just suppose we have this contract, which is the new version of the staking pool contract, and when when a staking pool is touched through some delegation or some other action, when this account is touched, we essentially would just say we swap the contract on the state level. So basically we say, okay, now we just swap in the new contract, and then we execute the new contract instead of the old contract. And this allows us to directly upgrade the staking pools without having to go through either the manual migration or having this additional action. And this also allows us to say that we can modify the staking action directly to take 3 arguments instead of 2, which is basically we can modify directly the staking action to take the SEC 256 K1 public key, in addition to the ED2519 public key. So now here is some more development on this front. Basically, there is a so I think after some discussion, people think, yeah, this looks better than what is proposed before. But there is some disagreement as to how this should be done exactly. For example, Evgeny proposed that we don't modify the stake action in a backward non-compatible way, but we introduce a new action that new stake 2 action that just adds the SEC 256 key, and then later deprecate the stake action. So let me elaborate more on the reasoning behind Elias' proposal, and why it is even it is even feasible to do it in a backward non-compatible way. The reasoning is that today on mainnet, no one actually uses stake action directly. So no one basically sends stake action, a transaction that contains a stake action directly. All the validation is done through staking pool contract. Essentially, the only place where stake action is involved is inside the staking pool contract, and there's no one, as far as we are aware of, that tries to use the stake action directly. And because of that, it gives us the opportunity to say that because no one actually uses this, we can afford to do it in this backward non-compatible way, and we just say we modify stake action to take to now take a ED251, a public key, yeah, and if we do this upgrade, everything on mainnet was still going to work, because no one actually, no one today actually just sends a staking transaction directly. Now there are some implications, right? So the tools will, you know, they also need to do this non-backward compatible change, and this will break things on betanet and on testnet, for example, where we do actually send staking transactions directly. However, it is considered that the effect of that is quite minimal, and we do not, and it is not considered to be a deal breaker, at least in this case. So this is, yeah, so I think we can, this is one thing that we can discuss later. So I think I covered most of the changes that we need to make. So before we open up the discussion, I want to basically summarize, to present the summary of what people have been discussing so far in the past a week or two on this topic. And yeah, after that we can open up the discussion, and if people have questions, yeah, we can answer them. So far it seems that everyone is on board with the necessity of adding this validator secp. However, there's some disagreement on how exactly we want to do it. So on the bridge side, I think there's some disagreement on what exactly is the message that should be signed by the secp. That is fine. We can take more time to finalize this. And I think Evgeny has some new ideas. But the important thing is that I think we agree there needs to be some message that needs to be signed by the secp, and that will be added on to the block. And now on the protocol, on other protocol changes, it seems that we all agree that adding this, doing this upgrade through the runtime by swapping the contracts directly is better than the other options that we've discussed so far. And there's some disagreement as to how exactly we want to do this part. And the third point is that we don't want to introduce BLS key at this point, because we don't know which exact curve we want to use. And for the changes on the tooling side, it basically will mostly be inside in near API.js and near CLI. And the changes are mostly to account for the change in transaction structure, basically the addition of new actions. And because of that, there needs to be corresponding change in both near API.js and near CLI. And of course, we need to write a new staking pool contract. Okay, I think I talked about a lot. So before we discuss some of the details, do people have immediate questions right now regarding what I've discussed so far?
Did you say that betanet and testnet use the action directly? I'm a little confused on that.
Yes.
Okay.
I would also comment that, like,
modifying a live action will break even the mainnet, because you essentially, once you swap it on a protocol level, it means the previous pools immediately stop working until you provide this secp key. So you cannot restake, you cannot do anything, because the old action just doesn't work. So even if we upgraded the pool, but the secp key is not provided yet, they can't restake. So the release has to be done in like multi-step process.
Yep.
With like multiple protocol upgrades. So let's say the first one, we modify the staking pool contract to allow this new action, either through upgrade or like through straight built-in it into the new contract. I would say it's better to be done with upgrade functionality, because we don't need to modify state and we allow future upgrades.
Okay.
Then the second, what you would do, you essentially ask all validators to upgrade their staking pools and provide secp key as part of the upgrade. At the same time, when you do an upgrade, you can actually introduce the new secp or stake action 2, which is no op. So you start accepting it, but not acting on secp key. So it just ignored. It acts like a standard stake action. And once you satisfy it with the amount, like all validators who like 80% upgraded their staking pools and provided their secp key, we can swap to the next protocol, which deprecates the previous stake action and introduces the stake action 2 as the main one. And at this moment, we start enforcing that secp key 2 is required to be considered a valid block.
Yeah,
but we need more than 2 epochs to the upgrade of staking pools, because
I think we can. I want to postpone this. I'll talk about the upgrade process here. Let's see if people have other questions before we talk about discuss that in more detail.
So the secp there, that's really. Is there any use within the Near ecosystem itself, or is this more just for integrating with other blockchains?
I think the bridge is part of Near ecosystem, right? I don't think we view it as something that's completely different. As to the use of this key, it is a validator key, right? So I don't think you today use your ED2519 validator key for something else other than validation. You shouldn't really. It's not clear what exactly is the question, or what exactly do you want to know?
I think that cleared it up. Yeah, it did. It's just signing a transaction level.
No, it's not signing on the transaction level, because validator keys cannot be used, or should not be used as account keys that can send transactions. You can use it as for like one of your account keys, but that would be a very bad practice.
Henry, literally what you're going to do with this key is you're going to send like a message. It is not a transaction that is accepted by the Near blockchain, but you will send a message like, I acknowledge as a validator that this particular block is correct. Something like that. You can treat this way. And because of the difference of the cryptography that is used in Ethereum and Bitcoin and in Near, in Ethereum and Bitcoin, it is much easier to use this specific cryptography to check the fact that you are okay with this block, that this block is correct. It is much easier than checking the Edward curves that is used in Near protocol. So that's it. So it's not a transaction; it's just an acknowledgement from the validator side that a block is adequate, is built according to the consensus rules.
There's nothing. Yeah, there's nothing that's really related to transactions with the addition of this key. I mean, it is a validator key, right? So the nature of validator key is that they use to sign things related to consensus, and they should not be used as to sign other things. And I mean that would pose security concerns.
Okay, no, that makes sense. I just, you said a little bit ago that the Near API JS and those things would be updated based on that at the transaction level. So that's what I was inquiring about. But
okay, yeah. To clarify on the transaction side, what we're talking about is the addition of new actions. So that requires change to the obviously to transactions, and then because of that, all our tools need to support that. But that doesn't mean that this transaction is signed by the validator key. I mean, there's no change there. It's simply that we add a new action. So basically would be a new type of transaction you can think of that way.
Yeah, one additional thing that I would like to bring on the table here, it is actually pretty much aligned with one of the Elias comments, is that for validators, adding of the additional key means that you would need to generate it. And since many of you are using multi-server approach, how you are like having the nodes running, so in case there is an outage in one server, then the other is able to continue the operations. So you would need also to securely move this key from one server to another. That's the same as with your Edward curves keys that you are using at the moment, but still you would need to securely generate the key and securely move this key. So that would be an additional like pain to you, well, like an additional step, I would say. And so this is going to be an important thing to you. In the maintenance procedures, you would need to make sure that both keys are secured, and you are like 100% sure that nobody is able to get an access to these keys.
Can I have a comment on this? So it is possible to use the same seed to derive any number of private keys that may be using completely different curves. So it will not be possible to derive one public key from another public key like in HD wallets. But when you have a private seed, like random 32 bytes, I think that is currently used, you can use the same seed to derive multiple keys, and essentially you only need to store that single seed, and that's it. So if we use the same seed that already exists, we may avoid the need to have validators move additional private keys between servers, and it will simplify the operations, because they would only need to securely store just one seed.
Yeah, so probably need to discuss this in detail more, but I'm just trying to point out what are like the consequences of this decision for the validators.
Yeah, thanks Alex for bringing that up. Yeah, I want to make it clear to the validator on this call. Yes, that means you do need to maintain an additional key, and at this point, Near does not support remote signing or like HSMs. So it does mean that for your operation, in case you need to transfer keys, you need to transfer both keys. But as Evgeny pointed out, there could be ways that we can simplify this. But yeah, anyways, you need to maintain one additional key in addition to the ED2519 key you have. So yeah, I want to make that clear to validators on this call.
And would the ED key eventually be phased out, or I mean, because it seems
no, well, at least we do not. I don't think we plan to phase it out anytime soon, or there's no plan on changing that.
So there'll just be it'll be signed in two different ways, essentially.
Not exactly. The sec key is used to sign a different message. It's used to sign some specific message, and the ED2519 key would sign other things. Yeah, it's on the protocol level, basically. So basically, the current proposal is that the sec key will sign this the specific message containing some specific things that bridge needs. But this may be subject to change. But yeah, I mean, all of this is on the protocol level. So I think as a validator, I think the two keys are, I guess, equally important to you in a way, because your node cannot function without either. After we do this change.
Yeah, from the protocol perspective, the primary key is Edwards curve key, and all the messages that your node is sending is signed with this one. And SEP key is used only to help help to operate the bridges with Ethereum and in future with Bitcoin.
Okay. Does anyone else have any questions? If not, we can talk more about how the upgrade process is going to work. Okay, let's discuss it. So initially, well, the initial proposal I have is that, as Evgeny said, this is going to be a multiple-step upgrade process. So first of all, we're going to make the protocol change that change the approval and the block structures and to add sub key signatures. This is purely a structural change to some of the primitives we have on the protocol level. And at this point, none of the signatures will be enforced. Basically, simply adds it in the structure and to account for that. And the second step is that we well, yeah, it depends on how we do it, but this step we will basically change the action. We can discuss more here. Basically, at this step, we're introducing the necessary action to account for the addition of sec key, and you can stake with that key. But that's this step. The signature is still not verified. Now, after all the validators have kind of registered the sec key in one way or another, depending on how we do it, we basically say, okay, now is the time to turn on the check for sec key signatures, and after that the upgrade is fully finished. I think the kind of contention is how exactly we do this second step, and this relates on how exactly we do the change with sec key. I mean, how we do the modification to the stake action. I think Evgeny is saying that we should add a stake 2 action, which would essentially be no op at this stage. No. That will not be no op. It will trigger on the protocol level the recognition of the secp key as one of the validator keys, but it will not verify signatures at this point. But it only verify signature after step 3 is done. So at the same time, I think it is feasible to directly change the stake action to have to include a secp key. Yeah, so the way you do this is that when we do the upgrade, we swap the contract, at which point validators have an option to deploy a new contract, which will include the new staking action. However, during the period between the protocol upgrade and they deploy the new staking pool contract, the staking pool is essentially frozen. No operations can be done to it because the action is deprecated. I think that's
think so.
Why?
No, the upgrade should be, we basically introduce the new action, but still use the old action. The new action acts like the first action. Basically, secp key can be ignored.
I'm talking about I'm talking about directly modify the stake action.
Oh, yeah, sure. Yeah, that's idea is not good.
Okay. So what? So can you elaborate on why it is not good, other than there will be a time period where the staking pool would be completely frozen?
Well, I just don't see breaking changes as a good idea to live protocol.
Okay.
Like, when you don't give time to the upgrade, so everything should be done like this two-step where we first reintroduce a new way and then only after this deprecate the old way once sufficient number of validators upgrade. And because if
Okay, let's maybe talk more about this, and well, I hope we can reach some conclusion at the end of this meeting. So let's think about the implications, right? So either let's say we modify the stake action directly, or we introduce a new change. So if we modify the stake action directly, we still need to do the corresponding change to all the tools to account for this change. The amount of work that needs to be done there is, I would say, maybe similar to the amount of work you would do to introduce a new action. And I guess the advantage, well, actually, I don't. I think maybe there's no advantage, because you still need to. So let's say we do this change, we change the stake action directly. The archival nodes still need to know the old action. They still need to apply the old blocks depending on the protocol version. They still need to maintain some they still need to. Yeah, they still need to maintain that kind of ability to apply that old action, which is potentially even more annoying. And yeah, the change it directly also breaks the what we have on beta and testnet, for example. Yeah, so actually at this point, I don't actually see an argument for directly modifying the stake action. Actually, is Elias? Yeah, I don't think Elias is here. So he proposed to do it directly, but Okay, so his concern is what happens if yeah, so we will deprecate the stake action after we do this change. So I guess the downside is that you will have some action that is deprecated, but you can still you can technically still send a transaction with that action, and then it will just be rejected. But I don't think that is a big deal. We just will deprecate support on our tools as well. And then if you want to manually construct some transaction with that action, sure, I mean you can do it, but I don't think that would be a big issue for us.
Which might be good time to upgrade our deserialization errors to be generic error. So instead of giving like specific deserialization error, it should just reject in general, like cannot deserialize. If you have like some specific piece, saying like, hey, that's like unexpected. So remove Borg specific errors and replace them with like generic errors on the next protocol, if it's possible.
Well, okay, I see. So you want to directly remove that old action from the transaction, the possible action.
Yeah, no, I don't think you need to, but
yeah,
like maybe
yep.
a node
but
eventually will be able to just like ignore this.
Yeah, I think they will ignore, but I don't think the error would be on the deserialization side, right? Or unless you want to modify how you want to have like custom implementation for Borg to say like, maybe, oh, if it deserialized to this like variant, let's just reject it.
We can like have a mark, something like deprecated. Or like
deprecated. Okay,
some deprecated.
macro magic directly rejected. Okay, that sounds good.
One question I do not understand right now. As far as I get in this discussion somewhere, it was the part about the upgradability of the contracts that are used by pools. Is it something that we are considering introducing also within this upgrade, or it is like a fully separate topic? Because as far as I get it, at the moment, validators are not able to upgrade their smart contract. Is this correct?
Yes. Yeah. This upgrade is done on the protocol level. It's like we apply this heavy artillery to just do it on the protocol level, not on the smart contract level. And this upgrade because the current validator, the staking pools, they're set up in a way that is, you just cannot do it because they don't have any keys. It is completely permissionless. And in regards to smart contract upgrade, I think Evgeny might have some more to say about that.
Yeah, so the only problem I see with smart contract upgrade on a protocol level is we don't want to modify the state of the contract because it's gonna get messy if we do this. When we replace a binary, the problem is because the staking pool still has to go through some foundation account. The only way for us to define this foundation account without modifying the state is hard-coded straight to the contract. That will affect testnet, where if you use the same binary on a testnet, then it will point to some hard-coded account on a testnet, which is not a mainnet account. And this testnet account essentially will have to guard it has to guard what is the like contract can be deployed on top of the staking pool. Like what's the next version that you can select? Because we cannot allow to deploy any version of the staking pools. So, but at the same time, we want to enable generic upgradability. So one option to solve this is we hard code the next hash towards which you can upgrade. And this hash will also have ability to set it by foundation, for example. I'm not totally sure how the upgrade should go, as long as we don't touch the state. Otherwise, you'll get into effect where the account gonna get in inconsistent state because storage usage has to be upgraded as well.
Yeah. Okay. So let's move the contract upgradability discussion to some other place. Actually, there is an NEP created by Ilya with regard to this.
No, this is different.
Yeah, this is different. This is
Oh,
a specific
okay.
upgrade. That's to it's not general smart contract upgrade. Yeah, so because this has to be done on the protocol level, and I think what Evgeny said is that how we're going to do it exactly, because of the need to get whitelisted by the NEAR Foundation. I mean, we can say that we can have a hard-coded hash, or we can say So what is the problem with let the validator deploy their contract, and then they need to be responsible. They need to make sure it's deployed in the right way.
Because it can steal lockup funds.
And steal lockup funds. What do you mean?
So the reason why validators don't have control over the code is the funds
I see. I see what you mean.
on a validator on the staking pool. Because staking pool does not allow to withdraw funds outside of the logic.
Good point.
So
okay, maybe we have to do hard-coded hash then.
But even hard-coded hash, like we essentially do an upgrade to a hard-coded hash, which is
to have a hard-coded hash, we need to know the new code in advance, and we want in the future to do upgrade without knowing the code that we're going to upgrade to now. So we, instead of a hash which freezes, like makes us know in advance what we're upgrading to, we need some feature like we have a trusted account, perhaps hard-coded, which we can use to introduce a new upgrade, which we perhaps don't have the code, for which we don't have code at the moment. Like in the future, maybe we will have some other reason to upgrade pool contracts. Then we can use Foundation account that we control and trust to whitelist the whole code hashes that we can upgrade to. So these pool contracts need to check with this Foundation account before an upgrade to make sure that this upgrade is permitted.
And this Foundation account is different on different networks. That's why I say it's also problematic. So we can derive it from...
We can do conditional compilation, produce different binary for different networks, like some feature flags or some other use some other Rust functionality for this.
Yeah, that's a tricky one.
Yeah, I mean, like, I don't think that's...
We can solve it.
Yeah,
we can solve it from... Okay. So yeah, to summarize what needs to happen.
We can actually introduce a host function that returns chain ID, like there is a chain ID of code in Ethereum.
Okay. I mean, we do have a name of the current pool that we can use to extract the Foundation account. So we have its ending with like pool v1.near. So we can say that pool v1.near, which is a factory, will be responsible, or .near will be responsible. Anyway, I just want to summarize the decision and the process that needs to happen. So there is going to be a protocol upgrade number 1 that will prepare a staking pool to introduce an upgrade method, then introduce new staking action, and at this stage, the new staking action, even if it takes secp, the secp key is not required yet to have. And the second upgrade will enforce a secp key to be present and deprecate the alt action.
Yep. Okay, so any more questions? I think we have 2 minutes left.
Eddie, Mike, is everything good for you? What questions do you have?
Did you say me?
No, I see. I say Mike from Lunanova.
Hi, thank you very much for hosting this debate, which I think has been really interesting. Let me say I'm not the technical person on our team. I tend to focus more on governance and things like that. And so one thing that does strike me, though, is that at the moment there is a little bit of indecision about how to do the detailed execution of this. When do you think those things will be finalized? When do you think there might be a sort of clear plan? And I just wanted just to check that there would be some testing done before this is implemented.
That's a very good question, Bowen. Since it is going to be your team who's going to do this.
Yeah, I think we will write an app to detail to turn this into a more technical spec on how exactly everything is going to be done. Well, I hope that's going to be done in the upcoming weeks. And then after that is finalized, we can actually work on the implementation.
Can we actually test this upgrade on the testnet? Well, we should do this for sure.
Well, I mean, yeah, we can. I don't see anything stopping us from doing that.
Mm-hmm.
Okay.
I mean, right now, every new protocol change, every new protocol feature will have to first go through Night 3 and test it on BetaNet. And then after we think it's sufficiently stable, we will push to testnet.
Okay.
Yeah.
Do you have some time in mind? Do you think this is something that can happen in Q1 or it's more on Q2?
Yeah, it's hard to say. This could potentially take. Yeah, I don't have a very good estimation at this moment.
Okay.
Thank you.
Okay, yeah, I think we're a bit over time. So yeah, thanks everyone for joining. And yeah, see you. Have a good day. Bye.